Hello and welcome you to my video classes on concrete technology. And today we are mainly discussing about high strength concrete, and in short form it is known as HSC. So myself Vishwanath Auti, and we will see the today's content. And today we are mainly discussing in this video introduction part of high strength concrete, materials used for high strength concrete, some of the advantages, disadvantages and applications of high strength concrete. So now we'll go through introduction part. In the introduction first we have to understand how it is differ from normal concrete and how it is called, why so it is called as high strength concrete. So high strength concrete may be defined as as a concrete with a specified, so it is a concrete, no doubt at all, it is a concrete, but it is specified, mainly specified characteristic of cube strength, mainly it is characteristic cube strength between 60 to 100 newton per mm square. So it is mainly related to strength, that's why it is called as a high strength concrete. If you take normal concrete, it is strength will be lower than this, and if you want to get a higher strength, and it is also like no possible, but those kind of concretes are called as high strength concrete. Why? Because their specified characteristic strength of the concrete is between 60 to 100 newton per mm square, as well as more than the characteristic strength. Even it is more than 100 also, even they are going with ultra high strength concrete. If you take the high strength concrete, again it has some different types. One is high strength concrete and ultra high strength concrete, right? So I think you understood, it is mainly related to strength of the concrete and mainly of compressive strength. Next is, as I told, even it is they are going higher values also. So higher values means what? 80 to 100 newton per mm square, as well as even higher, being used for both pre-cost. Pre-cost means what? It is what? Some of the structures which are using for construction activities, they are already prepared in the industries, are like pre-stressed concrete. So maybe like no beam or slabs, they will prepare in industry and they will transport to site of the construction, right? So those are called as a pre-cost. And even inside to work, inside to work means what? As exactly where exactly is required, on there only they will pour the concrete. So it is what? Pouring of concrete, and it is also called as inside to placement of concrete. Next is some of the applications. The main applications of high strength concrete is inside to concrete construction, inside to concrete construction, or in offshore structures, columns of tall building, columns of tall building, mainly it is what? Columns of tall building, and long span bridges, long span bridges, you can see long span bridges and tall buildings, right? Long span bridges and tall buildings, and highway structures, as well as even highway structures. Next is the main advantages in the main advantages of high strength concrete is reduction in the size of the compressive element, right? Reduction in the size of compressive element, and the amount of longitudinal reinforcement required, the amount of longitudinal reinforcement is required. So here it is what advantages are: one is reduction in the size of the structure, as well as reduction in the steel requirement. So next, so materials used for high strength concrete, so different materials will be used, right? So here also we are not, it is not differ from normal concrete. Whatever we are using for materials for normal concrete preparation, here also they are using, but slight, it is not a very high difference, only a little difference is there, right? So we'll get to know one by one. So first one is water. So water is one of the material which is used to mix the different materials, right? So here water is required in the form of clean, fresh and free from contaminations. So clean, fresh, free from contaminations. Then the main target of water cement ratio is 0.3 to 35. So main target is what? 0.3 to 35, even lower than that also. So that's what water will take main part. So next is cement. So cement we are using as a binding material, right? So here all type of cements are allowed, all type of cements are they're using, but mainly they are preferring for high strength concrete is low C3A cement. Low C3 cement are desired because it increases the or it improves the rheology, right? It's mainly one of the property which gives a good property to the concrete. So cement content used below 500 kg per meter cube. So actually if you are constructing any structure, then cement used for that construction should be less than 500 kg per meter cube. Why? Because if you use more, then it increases the brittleness, it may cause some problem. And even to reduce the material cost of the concrete, even for to reduce the material cost of the concrete, because economy or investment is very important. If you have a good investment, then only you can good construction of the good structure and other more facilities, right? So that's what cost is also main important. Next is use of mineral admixtures. So why I used this word? Because these are the mineral admixtures are additive or replacement of cementitious material or supplementary cementitious material. And even why you are focusing on mixing of mineral admixtures, because even it is related to solid waste management. Why? Because whatever mineral admixtures we are using, those are some of the waste products from or byproducts from some of the industries, right? We required industries as well as we required management of nature. So we are reducing the disposal problem as well as replacement of cement material. Why? Because we know cement makes the heat of hydration. From the heat of hydration, it reduces the heat as well as carbon dioxide. So even we are reducing the carbon dioxide, even we are reducing the heat, and even we are making the solid waste management by using mineral admixtures. So we'll see what are the different mineral admixtures we are using. So one is blast furnace, right? So we know what you mean by blast furnace. Blast furnace is one of the byproduct from steel production or steel manufacturing unit, right? So then fly ash. So fly ash is one of the byproduct from thermal power plant. And silica fume. So silica fume we not studied in earlier videos. So but here we have to understand what you mean by silica fume. So from which industry it is becoming a byproduct or waste product. So actually silica fume is a byproduct from producing from silica metal. So when you are producing silica metal, so during the production of silica metal, so silica fume as one of the byproduct or waste product, and it is very reactive material, very reactive pozzolana material. So because that's what, because of this characteristic they are using as a mineral admixtures. And natural pozzolana, even natural pozzolana materials are used, and mainly it is because of reduction in the production cost, reduction of cost of concrete, and even to tackle slump loss issues, even to tackle slump loss issues. So we'll see next materials which are used for preparation of high strength concrete. So next is aggregates. We know aggregates are taken main role, right? So we'll see what kind of different requirements are required to prepare the high strength concrete. So one by one. So first I will take coarse aggregate. So coarse aggregate are mainly preferable are crushed rock aggregate. So if you have a crushed rock aggregate, this is very good, and mainly higher crushing values. If you have higher crushing values of aggregate, then it is very good, right? And maximum size of aggregate for high strength concrete, it ranges from 10 to 20 mm or even up to 20 mm are even we are using, because based on some conditions, because all type of materials are not available in all the places, right? So if you want to get some certain strength, right? Why I told high strength concrete, in high strength concrete again we have some types. One is high strength concrete or ultra high strength concrete, so and so, because it is recent technology, some even research are going on this product, right? So if you want to get a compressive strength of normal strength, it is 70 MPa, right, or 70 Newton per mm square. Then the restriction of aggregate is ranges from 20 to 28 mm. Even normal it is actually. If you want to construct high strength concrete, or if you want to produce strength concrete of 70 MPa, then no problem, we can use maximum size up to 20 to 28, but if you want to get a highest strength, right? So if you want to get a highest strength of compressive strength of 100 MPa, so here it is what, 100 MPa. So it is increasing the compressive strength. If you want to increase, then the restriction is you have to use within this only of 10 to 20. So earlier it is 20 to 28, but here it is 10 to 20, right? So if you want to again increase the strength, right, again 25 MPa, see from 70 to 100, 30 MPa increased. Same from 100 to 125, 25 MPa is increased. Why? Because it is a change in the aggregate, right? So here it is aggregate size maximum we are using from 10 to 14 mm, 10 to 14 mm. So next we will go for fine aggregate. So even fine aggregate takes the main role. So here fine aggregate with the fineness modulus about 3. So fineness modulus is how much is required? 3 is required, right? So gives the best workability. So if you use the 3 modulus, fineness modulus, then it gives the best workability and compressive strength. Even it gives the best compressive strength as well as workability. And well graded fine aggregate helps in reducing the quantity of paste. So even it helps the reducing the quantity of paste, right? So then increases the economy and improves the unit weight, even improves the unit weight, and even the bond also, the bond between coarse aggregate and fine aggregate and even other materials also. If you use a well graded and a fineness modulus of 3, then it gives the good bonding also. So next is use of chemical admixtures. Earlier it is what, mineral admixtures, it is now chemical admixtures. So chemical admixtures means super plasticizers. So mainly plasticizers and super plasticizers we are using for high range water reducer. It is also called as high range water reducer, should be used to achieve maximum water reduction. So mainly it is what, reduce of maximum water use, right? So it is a reduction, not increasing, it is reducing of water, right? So even we can reduce up to 30% of water requirement. If you go for normal concrete preparation, how much water is required? Compared to that, we can reduce 30% of water. For example, 1 liter you are using the water, then you can use only of 700 ml of water we can use for construction of concrete, right? Why? Because 30% we can reduce. Next, we'll see advantages of high strength concrete one by one. So first advantage or main advantage is reduction of size of compressive element. As I told in the first slide, it is reduction in size of compressive element, right? So next is reduction in amount of longitudinal reinforcement. So here it is, both are very important. When you are reducing the size of the structure, even it helps in reduction in the cost, as well as even if you reduce the steel content, it also helps the reduction of the cost, right? So next, some of the advantages in terms of properties or strength. So here high strength concrete provides high compressive strength, we know, right? It is mainly related to high strength concrete. So then even it gives the high modulus of elasticity, even it gives the high tensile strength, even it reduces the creep and greater durability than the normal concrete. Whatever here we are giving, high compressive strength, high modulus of elasticity, high tensile strength, reduces the creep, it is comparatively with normal concrete, it is comparison with the normal concrete. So next we will see disadvantages of high strength concrete. So still research is going, and mainly most of the disadvantages are due to lack of adequate research. Research is going on, and mainly is research of field condition. Why? Because in laboratory we can make the testing, but the result in the site is different. And we'll see some disadvantages. One is damaged at high temperature, means less fire resistance, it has a less fire resistance, and must be expertise in a selection of ingredient. So one is what, it has a less fire resistance, and you required more expertise, you required more knowledge, you required more skill to select the material. Why? Because I told how many important conditions are there, otherwise it will make the a wrong concrete preparation and you won't get any strength, then it will become a normal concrete. If you want to get a high strength concrete, then you have to be very careful for selecting of materials, right? So next, applications of high strength concrete. So where exactly we are using, and we are using in almost all the places, but mainly where they are preferring to use high strength concrete. So here one is, high strength concrete is typically used in erection of high rise structures. So main is what? Erection of high sized structures, high high rise structures. So next, it has been used in components such as column, high-rise structures, but mainly it is components such as column, and mainly it is what? For lower floor. So if you see, if you take the size of the column in lower floor, it is bigger and it has a more load. Why it is a bigger? Because it carries the more load. Because if you see, first floor, it has a only load of first floor, right? Sorry, if you take a not first floor, if you take a ground floor, it has a load of first floor, second floor and third floor if it is a third floor building. And if you take the first floor, it has carrying only load of second floor and third floor. If you take the second floor, it is carrying the load of third floor. So when the floors are decreasing, if you go for ground floor, it carries the more load. And mainly for column in a lower floor, they are using high strength concrete. High strength concrete. So next is high strength. Strength also used, occasionally used in bridge applications, even for bridge construction. Mainly it is what? Long span bridges. Long span bridges they are using. Next is, some recent include parking garage. So if you see the parking garage means what? For example, those are like a structures, and even like they are buildings, and mainly they are constructing to make the parking, or you can call it as a multi-story parking garages, or you can, like, depends on the construction. If it may be a one floor, it may be a two floor, it may be go up to 15 floor, but it is multi-story parking of vehicles, and even they can use for that, and even for construction of warehouses and as well as other highway structures, even for other highway structures. So next is, high strength concrete is typically used for dam construction also. Even you can use for dam construction. You can see here also long span bridge is there and even dam is there. So here also they use the high strength concrete even for bridges, and mainly for long span bridges and even for precast bridges, right? I think you understood, right? So thank you for watching my video.